Hello everyone, in this video we are going to discuss about some special types of functions and inverse functions. So let us start with these special types of functions. So the very first one is injective function. This function is also known as one-one function. This function is also known as one-one function. A function is known as injective when for two variables, suppose x1, which is not equal to variable x2, fx1 is also not equal to fx2. Basically, let me explain it to you with an example of set. Let this be set A and let this be set B. Here's the set 1, 2, 3, 4, and here A, B, C, D, E, or something like this. Now, let us see how does this work. So, for this particular function defined from A to B to be an injective function, every element or every pre-image must have only one image, and there should not be any other pre-image or any other number or any other element which has the same image. For example, suppose here one has a image A, so two can't have a image A. Two different elements can't have same value of their function. I hope you understand this. So I hope you understand injective function. And when a function is injective, then we can also say that this f is an injection. F is an injection. I hope you understand this. Now we will move on to the second type of function. The second type of function is surjective function. The second type of function is surjective function. Surjective function is kind of function where the range is equal to the codomain. In the last lecture, I had explained you what does codomain mean. If you have not gone through that lecture, you can go through that lecture. Now, what's surjective function? Let us again give you an example. Let this be set A and let this be set B. Now suppose set A has three elements 1, 2 and 3, and set B has three elements A, B and C. So in this case, something like this. This is called surjective function where all the elements in set B have a pre-image, where all the elements of codomain, I hope you understand what a codomain is. If you don't, you can watch the last video, where all the elements of codomain are elements of set or are part of range. I'm sorry, not set but rather range. I hope this is clear to you. These were the two types of functions. Now there is one more type of function which we call bijective function. What do we call this function? Bijective. Now here comes a word bi. So bi is used when there are two things. So a bijective function is a function which is both injective and surjective. So again, a bijective function is a function which is both injective and surjective. I hope this is clear. For example, this could be a bijective function. Why? Because here it is injective because every element have different images, and it is surjective because all the elements of codomain are in range. So this is bijective as well. I hope you understand till here. Now we will move on to inverse functions. So let us turn the page and understand inverse functions. Let us continue with inverse functions. But while talking about inverse functions, we must keep something in our mind. And what is that thing? Let me tell you really. So that thing is that inverse function is only defined for a function which is bijective. Let me again repeat it. Only defined for functions which is bijective. For function which is bijective. This is one thing that you have to keep in your mind. Otherwise, you're gonna do mistakes. Inverse function is only defined for those kind of sets which are, sorry, those kind of functions which are bijective. It is not defined for any other kind of function. Let this be very clear to you. Now, let's go into the definition. So suppose f is a function from set A to B, which is a bijection, bijection, which is a bijection. So a set G would be said to be inverse function. Suppose there is a set G. This set G, sorry, function set G would be defined from B to A, and it would be called inverse function, where it would contain elements such as B comma A, where B belongs to B and small a belongs to the set A, and A comma B belongs to F. This is something that you have to keep in your mind. This is the very basic term of inverse functions. Also, inverse functions are sometimes denoted as f inverse. So we must keep this in our mind. Whenever you see f inverse or f to the power minus 1, it is denoting a inverse function. Now, there are some places where we have functions which are not inverse themselves, but we have to make them inverse by changing their domain, by changing their range. These kind of functions are trigonometric functions. If you want to know more about it, I will post a video regarding this, how to convert functions. That is not something that is the main point. Inverse function is enough to read the remaining parts of real analysis. So we will be moving on with inverse functions right here. Okay. Other than this, now I will make you understand it even bit more deeply. So bijection, I hope you have understood. Let me give you just a basic example so that it could be more clear to you, and then we will end with this video, and I will post some questions in the community section. Please solve them. The solutions will be either provided in the short section or in the next video, so please solve them. Let A and B be two sets, and let f be a function. Now let 1, 2, 3 and 4 be the elements of set A, and let A, B, C and D be elements of set B. Now in this case, suppose one's image is A, two's image is C, the image of 3 is B, and the image of 4 is D. Now here you can see that all the different elements in set A has different images in set B, so we can say that it is injective. Other than this, we can see that entire codomain is the range, so we can also say that this is surjective. So if it is injective as well as surjective, then we can say that it's bijective. And if this function is bijective, then there must exist its inverse. So let this be f inverse. So what would be f inverse? Let me again make a diagram for you and make it more clear to you. F inverse would be defined from set B to set A. This is the set B and this is set A. Let me write the different elements of set B. So the elements were A, B, C and D. The elements here were 1, 2, 3 and 4. Now when we define the inverse function, that is f inverse, or you may say it as G, no problem with that. When we define the inverse function, then how would it be defined? A have image A, sorry 1, B will have the image 3, C will have the image 2. So keep this in mind that for an inverse function, the image of any element would be the pre-image that is in its original function. Like in F, the pre-image of B was 3. So here the image of B is 3 and D will have the image 4. Now, if someone asks you what would be F inverse B, then you can simply say 3. I hope you have understood this. With this, we have come to an end of the topic, that is different types of functions and inverse functions. I hope the video was helpful to you. I will post some questions in the community section, and also to notify you that I have started a series on electrodynamics. So any of you who want some help in electrodynamics can go through that series. Thank you very much.